everyone, and welcome back to our YouTube channel. This is Mathematics with Engineer Abs. Now, today I want us to look at something which is not different, derivative from the first principle. We look at this, in our first video. And today I thought of, using this method so that most of our viewers can get it easy to follow using this principle or this method. Now, the question is y is equal to 2x squared plus 4x minus 2. Now, we want to look at it from the definition of the derivative. So the first step, solution. Let's look at the solution. But before we look at this problem, in case you're watching us for the very first time, please take a second or two, click that subscribe button so that the next time we produce a wonderful video like the one you just want to watch, YouTube will automatically notify you. So without any further ado, let's go back here. So in this solution, the first step, I want to say, let y to be the function of x. So let y to be the function of x. So we have function of x is equal to 2x squared plus 4x minus 2. Then from the definition of derivatives, then df over dx. Take note, when the limit h is tending to be 0, I'm going to talk about that. Then the function of x plus h minus the function of x all over h. So I want you to take note on that formula. And you can see that when the limit h, which is now the variable because it is changing, the variable there is x and the function of fx, you add the change to the variable which is x, you see, then minus the initial equation all over our h. So can we now take the function of x plus h so that we get it? So that is going to be 2 into x plus h, remember it is squared, plus 4 into x plus h minus 2. So can we expand? That is going to be 2. Expand this using the first identity of expansion. So this is going to be x squared plus 2xh plus h squared plus 4x plus 4h minus 2. So when you open up the bracket here, we get 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 2. So take note that this is now the f into bracket x plus h. So we want to substitute from our formula. Substitute back from our formula. I want us just to rub this. Just want to rub this. So let's proceed here. Let's proceed. So we know this is function x plus h. So we said that the function, as the limit h is tending to be 0, then fx plus h minus function of x over h. So can we now substitute? Remember this is function of x plus h, so let's just put it. So the df over the dx as h, limit h is tending to be 0, then can we now substitute? Back? 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 2. Now that is the function of hs minus, put this one all over the bracket, then minus the function of x, and you know, as you can see, the function of x was our y, which is now that initial equation, 2x squared plus 4x minus 2. This one is all over h. So we have 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 2. Open up the bracket. Class, when you open up the bracket by a negative, then everything here, the signs are going to change. So we have minus 2 4x, that is minus 2x squared minus 4x plus 2. This is all over h. I hope you're following. It's so easy. It's so easy. So easy. So we can see 2x squared and 2x squared will leave the system, and then 4x also will leave the system, negative 2, and that 2 will also leave the system. So we have, as the limit h is tending to be 0, then we are remaining with 4xh plus 2h squared plus 4h. As you can see, this and that and that and that all over h. So this one we have, divide h, everything there. We have 4x, we have 4x plus 2h plus 4. So we have the df over dx, as the limit h is tending to be 0. We have 4x plus 2, h plus 4. But now, be attentive here, as h is tending to be 0, coming small, tending to be small, tending to be smaller and smaller, then put where there's h with 0. So we have 4x plus 2, 0 plus 4. So our final answer, the derivative becomes 4x plus 4, as you can see. As easy as ABC class. Mathematics is very nice. Thank you so much for watching this wonderful video, and if you have any comment, just put in the comment section so that we can look at it. Thank you so much, and may you have a nice day. Bye bye.